Dear students, in this video we will be solving few sums of exercise 1.1 of the lesson complex numbers. Question number 1, simplify root of minus 16 plus 3 into root of minus 25 plus root of minus 36 minus root of minus 625. And the terms inside the root are the perfect square numbers with a negative sign. So these numbers can be written as, if negative sign is there in the root, then we will get I, imaginary number I. So root of 16I, the first term will be root of 16I, and second term is 3 into root of 25I plus root of 36I minus root of 625I, because each number, for example, minus root 16, root of minus 16 can be written as root of minus 1 into root of 16. So root of minus 1 is I. So root of 16 into I. Like that all the terms we will write. Next, we will find the square root of each term within the square root. That is root 16, 4, 4I, 3 into root 25I, 3 into 5I, root 36, 6, 6I minus root 625 minus 25I. Now we will simplify these terms. We will get the value as 0. Second question, to write the conjugates. Complex numbers are given. We will write the conjugate of this by reversing the sign of imaginary part only. So conjugate of 3 plus I is 3 minus I. Conjugate of 3 minus I is 3 plus I. And minus root 5 minus root 7I. We will reverse the sign of only the imaginary part. So minus root 5 as it is and plus root 7I. Minus root minus 5 is equal to minus root 5I, that we know because this is not given in the form of ordinary complex number. So we will remove I from this, then we can write this as minus root 5I. Then the conjugate is this, there exists only the imaginary part, so we will reverse its sign, that is root 5I is the conjugate. Next one 5I, again imaginary part, so minus 5I. Then root 5 minus I, then root 5 plus I, root 2 plus root 3I, then root 2 minus root 3I, and cos theta plus I sin theta, then its conjugate is cos theta minus I sin theta. Question number 3, find A and B if A plus 2B plus 2AI is equal to 4 plus 6I. There is an equation containing complex numbers, and we have to solve for A and B. Now we will compare this equation and the real and imaginary parts of the equation, that is A plus 2B is equal to 4, that is the term without I and the term with I are compared on both sides. So A plus 2B is the real part without I. So A plus 2B is equal to 4 in the right hand side and 2A is equal to 6. So 2A is equal to 6 means A is equal to 3. Now we will substitute this value in the first equation, that is A plus 2B is equal to 4. So A plus 2B equal to 4 means 3 plus 2B is equal to 4. 2B is equal to 4 minus 3, which is equal to 1. So B is equal to 1 upon 2. Next question, A plus B into 2 plus I is equal to B plus 1 into, B plus 1 plus 10 plus 2A into I. Now we will expand the brackets in the left hand side, that is A into 2, 2A plus A into I, AI plus B into 2, 2B plus B into I, BI is equal to B plus 1 plus 10 plus 2A into I. Now we will collect the terms without I together, that is 2A plus 2B plus, now A plus B into I is equal to B plus 1 plus 10 plus 2A into I. Now compare the real and imaginary parts on both sides. We will get 2A plus 2B is equal to B plus 1 and A plus B is equal to 10 plus 2A. Now 2A plus 2B is equal to B plus 1. 2a plus b, 2b minus b is equal to 1. And minus a plus b is equal to 10 plus 2a means 2a can be taken to the left, then it will be a minus 2a, that is minus a plus b is equal to 10. So we got two equations. Now we will solve these equations to get the value of a and b. Now we can subtract the equation 2 from equation 1, that is 2a. While we are subtracting this, b is the coefficient of b is same in both the equations, so we can remove b from both the equations at a time. So we will subtract 1 and 2, that is 2 from 1, then 2a minus a, that is 2a plus a, that is 3a, and right hand side will be 1 minus 10, that is minus 9. So 3a is equal to minus 9, a is equal to minus 3. Now substitute a is equal to minus 3 in equation number 2. Equation 2 is simple, so we will substitute in equation number 2. So minus a plus b is equal to 10 implies minus of minus 3. A is minus 3. So two negatives are coming together, then it will become 3 plus b is equal to 10. Then b is equal to 10 minus 3 is equal to 7. So a is equal to minus 3 and b is equal to 7. Now question number 5. 1 upon a plus ib is equal to 3 minus 2i. Now we can multiply both the side with a plus ib, then left hand side a plus ib will get cancelled and right hand side we will multiply with the 3 minus 2i. So 3 minus 2i into a plus ib is equal to 1. And expand the brackets, we will get 3a plus 2b plus I into 3b minus 2a. The steps you know very well, that's why I am going little fast. Is equal to 1. So we can write 1 plus 0 I, because left hand side there is complex number, that is real part and imaginary part. Right hand side only real part is there, so we can add a 0 I without changing the value. Now compare the real and imaginary parts. So 3a plus 2b is equal to 1 and 3b minus 2a is equal to 0. Now multiply the first equation by 2 and second equation by 3 and add. First equation if you multiply by 2, then it will be 6a plus 4b is equal to 2, and second equation will be 3b into 3. We are multiplying by 3. Then it is 9b minus 6a is equal to 0. So in both the equation the coefficients of a are equal. Then we will add. Then 6a and coefficients are equal but sign is opposite. So we can cancel a from both the equations. Now 9b plus 4b is equal to 13b is equal to 2 plus 0, that is 0. 2. Then 13b is equal to 2 means b is equal to 2 upon 13, and put this value in any of the equation, you can get 3b minus 2a. I took the second equation here, 3b minus 2a is equal to 0. So 3b minus 2a is equal to 0 implies 3 into b is 2 upon 13. So 3 into 2 16. 6 upon 13 is equal to 2a. A is equal to 2 will come below, that is in the denominator, then cancelled. So 3 upon 13. So 3 upon 13 is the value of a. Next one, question number 4. Express the following in the form of a plus ib, that is a, b are the real numbers and I is equal to root of minus 1. State the values of a and b. Now the second question I took, 1 plus I into 1 minus I inverse, 1 minus I whole raised to minus 1. Now 1 plus I into 1 minus I whole raised to minus 1 can be written as 1 plus I upon 1 minus I. Here the exponent is minus 1. If you take it to the denominator, the exponent will become positive. So 1 minus I raised to 1, that is 1 minus I. Now we will multiply the numerator and denominator by the conjugate of 1 minus I to remove the imaginary part from the denominator. So numerator will become 1 plus I into 1 plus I, that is 1 plus I the whole square, and denominator is a complex number and its conjugate, if you multiply, then you will get the square of the real part and square of the imaginary part are added. So 1 square plus 1 square, that is if a plus b and a plus ib and a minus ib are multiplied, then the value is a square plus b square. Now 1 plus I the whole square is 1 plus 2i plus I square. We will expand this as a plus b the whole square divided by 1 square plus 1 square 2. And I square is minus 1. So 1 and minus 1 got cancelled and you will get 2i upon 2, that is equal to I. And I can be written as 0 plus I of the form of a complex number. Now, which is of the form a plus ib, where a is equal to 0 and b is equal to 1. Coefficient of 1 is called the imaginary parts, that is b. So, coefficient of I is the imaginary part b, that is b is equal to 1. Now, fourth one, 2 plus I into 3 minus I into 1 plus 2I. So 2 plus I into 3 minus I into 1 plus 2I. Here denominator we will expand the brackets. So we will get 3 plus 5I plus 2, that is 5 plus 5I, that is 2 plus I upon 5 plus 5I, and we will multiply the numerator and denominator by the conjugate of the denominator. So we will get, on expanding the numerators, then 10 minus 10i plus 5i minus 5i square, and 5 plus 5i and the conjugate are multiplied, then we will get 5 square plus 5 square, that is 25 plus 25, that is 50. And on simplifying the numerator, we will get 15 minus 5i. Now we will separate the denominator to both the terms. Then 15 upon 50 plus minus 5i upon 50. Now we will simplify by cancelling the common factors on both numerator and denominator, that is 3 upon 10 plus minus 1 upon 10i is of the form a plus ib, where a is equal to 3 upon 10 and b is equal to minus 1 upon 10. Next one, 3 plus 2i upon 2 minus 5i plus 3 minus 2i upon 2 plus 5i. Now we will cross multiply the terms, that is 3 plus 2i into 2 plus 5i plus 3 minus 2i into 2 minus 5i, that is divided by 2 minus 5i into 2 plus 5i. And 2 minus 5i and 2 plus 5i are conjugate. So we will get what? 2 square, that is 4, and you can directly write 5 square 25 plus 5 square you can write. Then because I square is minus 1, then it will become 4 plus 25 only. Now numerator we will expand all the brackets. So 6 plus 15i plus 4i plus 10i square, that is the first two brackets we expanded. And then second two brackets, that is 6 minus 4i minus 15i plus 10i square. And numerator on simplification we will get 12 plus 20i square. Again I square is minus 1. So 12 minus 20 you will get, that is minus 8. And the denominator is 4 plus 25, that is 29. Now this is a real number. Now we can write this real number in the form of a complex number as minus 8 upon 29 plus 0i. Then this is of the form a plus bi, then where a is equal to minus 8 upon 29 and b is equal to 0. Ninth one, a little different question. 4 into I raised to 8 minus 3 into I raised to 9 plus 3 divided by 3 into I raised to 11 minus 4 into I raised to 10 minus 2. Now we will find the value of these higher powers of I and then simplify. And we know I raised to 8 can be expressed as, we will divide this exponent by 4 and write the remaining parts, that is remainder. That is 4 into I raised to 8 is I raised to 4 into 2 and I raised to 4 is 1. 1 raised to 2 is 1 itself. So we will get the first term as 4 only. Now the second term I raised to 9. So I raised to 4 into 2, that is I raised to 4 raised to 2 and one more I is left, that is 1 is the remainder, so I raised to 1 we will multiply, and I raised to 4 again 1 raised to 2 1, so 3 into I will get and plus 3. Denominator also will be done the same method, that is I raised to 4, I raised to 11 can be written as I raised to 4 into 2 plus 3, and we will expand this way. I raised to 4 raised to 2 into remainder is 3, so I raised to 3 is written. Minus 4 into I raised to 4 raised to 2 into I square minus 2, that is I square is minus 1, I cube is minus I, and I raised to 4 is 1. Now 3 raised to and we will substitute all these 1 values here and simplify. We will get 4 minus 3i plus 3 divided by minus 3i plus 4 minus 2, that is 7 minus 3i upon 2 minus 3i. Now we will simplify by multiplying the conjugate of denominator with the numerator and denominator, that is 7 minus 3i into 2 minus 3i, sorry 2 plus 3i, and 2 minus 3i into 2 plus 3i. That is conjugate of denominator is 2 plus 3i. So on both numerator and denominator are multiplied with the 2 plus 3i. Now on simplification we will get 23 plus 15i upon 13, that is 4i raised to 8 minus 3i raised to 9 plus 3, that is upon 3i raised to 11 minus 4i raised to 10 minus 2 is equal to 2. We will separate the denominator for both the real and imaginary parts, that is 23 upon 13 plus 15 upon 13i. So this is of the form a plus bi, where a is equal to 23 upon 13 and b is equal to 15 upon 13. Number 5 show that minus 1 plus root 3i the whole cube is a real number. Here we will expand this expression using the identity a plus b the whole cube. That is a plus b the whole cube is a cube plus 3a square b plus ab 3ab square plus b cube. Now the minus 1 is a and root 3i is b. So a cube plus 3a square b plus 3ab square plus b cube. Now minus 1 cube is minus 1 and minus 1 square is 1. So 3 into 1 3 root 3i minus 3 into minus 1 minus 3 and root 3i square. Root 3i the whole square is 3i square. Root 3 into root 3 is 3 and I square. So 3i square plus 3 into root 3i cube will come, because root 3 is coming 3 times. Root 3 is multiplied 3 times. So 2 times root 3 multiplied to get 3 itself. So 3 into 1 root 3 will remain. So 3 root 3 I cube. And I cube is minus 1. Sorry, minus I. So the last term will become minus 3 root 3 I. And minus 1 plus 3 root 3 I minus 3, because I square is minus 3 into 3i square is I square minus 1. So minus 3. 3 into minus 3 minus I cube is minus I. So this will become minus 3 root 3 I. And plus root 3i minus plus 3 root 3i minus 3 root 3i will get cancelled, and minus 3 into minus 3 plus 9. Minus 1 plus 9, 8. 8 is a real number. So we have proved this expression is a real number only. Now the remaining sums are solved in the next video. Thank you.